In this problem, we'll see how a loose electron can be accelerated across a potential difference. There's an electric field between these two plates. So if this is the positive plate of the setup, and this is the negative plate, the electron doesn't want to be near that negative plate. So it's going to be strongly repelled across the gap. Upon reaching the exit, the electron has a large velocity, v. And it's going to be now in a magnetic field, so we want to figure out which way is the curl going to be on this electron. So we can use the left-hand rule to do that. Imagine pointing your left pointer finger in the direction that the particle is going. We're going to need a middle finger that points into the page. And when we do this, we see that our thumb points down. This is the left-hand rule. We have V, B, and F. So the magnetic force on the particle, once it enters the region of magnetic field, will be downward. This will cause our particle to spiral in a clockwise fashion. It says here that our electron's speed upon leaving the gap is 100,000 meters per second. It also gives us the magnetic field strength. The question asks for the radius of the electron's path. So I'm going to use the formula R equals mv over qb. And it looks like we have everything we need in order to solve this. Mass of an electron is 9.11 times 10 to the minus 31 kilograms. Speed, 100,000 meters per second. We'll have our charge and our magnetic field. I'm getting an R of 7.12 times 10 to the minus 7 meters. Now, what would happen if the strength of the magnetic field were to increase? For that, we can analyze the formula for a radius. If the B field were to go up, then the radius would have to go down. They're inversely proportional. What would happen if the speed of the electron upon entering the magnetic field region were to increase, though? Since the speed is on top here, the radius and the speed are actually directly proportional. So our radius would increase.